Welcome to Expert Level Angular Interview Questions and Answers. Question number 1. How does Angular change detection work internally? Angular uses a unidirectional change detection mechanism that runs on browser events, HTTP responses, timers, promises, and observables. It checks the component tree from root to leaf, compares current values with previous ones, and updates the DOM if changes are found, with Zone.js automatically triggering detection. Question number 2. What is Zone.js and its role in Angular? Zone.js is a library that patches async APIs like setTimeout, HTTP, and events. It detects async operations, notifies Angular of changes, and triggers change detection automatically. Without it, Angular wouldn't know when to update the UI. Question number 3. What is Ivy Renderer? Ivy is Angular's new rendering engine, default since Angular 9. Benefits include faster compilation, smaller bundle size, better debugging, tree shaking support, and incremental compilation. Question number 4. What are standalone components? Standalone components allow you to create components without ng modules. Features include simplified architecture, faster bootstrapping, and better tree shaking. Example: here, standalone, true makes the component independent of ng modules, and common module is imported to use common directives like ngIf and ngFor. Question number 5. What is ahead-of-time compilation? AOT compilation converts Angular templates and TypeScript into JavaScript at build time. Benefits include faster app startup, better performance, early error detection, and smaller bundles. Question number 6. What is JIT versus AOT compilation? JIT, just-in-time, compilation in Angular occurs at runtime in the browser, making startup slower since the compiler must process templates on the fly. It is typically used during development for quicker iterations and easier debugging. AOT, ahead-of-time, compilation happens at build time, converting templates and TypeScript to efficient JavaScript beforehand for faster app startup. Production environments prefer AOT because it produces smaller bundles without the runtime compiler and catches errors early during builds. Key differences include JIT's runtime timing versus AOT's build time approach, with AOT offering superior performance, smaller sizes, and build time error detection compared to JIT's development-friendly but slower profile. Question number 7. How does Angular handle memory leaks? Angular manages memory leaks through built-in lifecycle hooks and utilities that automatically clean up resources when components are destroyed. The framework destroys components via NgOnDestroy, removes event listeners added through Angular APIs, and the async pipe automatically unsubscribes from observables in templates. Best practices include manually unsubscribing from observables in NgOnDestroy, using takeUntil with a destroy subject for multiple subscriptions, and avoiding global references or direct DOM manipulations that retain memory. Question number 8. How do you optimize Angular application performance? Angular optimizes application performance through targeted strategies that reduce bundle sizes, minimize change detection cycles, and improve rendering efficiency. Key techniques include using on-push change detection to limit checks to input changes, lazy loading modules to load code on demand, and track by functions in ngFor to avoid re-rendering entire lists. Additional practices involve pure pipes for efficient value transformations, enabling AOT compilation with production builds for smaller bundles and faster startup, and adopting standalone components for better tree shaking and simplified architecture. Question number 9. What is on-push change detection strategy? On-push change detection strategy instructs Angular to check a component for updates only under specific conditions, significantly boosting performance by skipping unnecessary checks. Angular triggers on-push detection when an input reference changes, a DOM event occurs on the component or its children, or an observable emits via the async pipe. This approach contrasts with the default strategy's constant checking, making on-push ideal for components with stable or immutable inputs that rarely change. Question number 10. What are dynamic components? Dynamic components in Angular are created and rendered programmatically at runtime rather than being statically defined in templates at compile time. Developers use them when the UI structure is unknown beforehand, such as rendering dynamic content based on user input, or for loading dialogues, modals, and overlays on demand without bloating the initial bundle. Modern Angular achieves this via view container ref and the create component method, allowing insertion into a container, input binding, and output handling for flexible, modular UIs. Question number 11. What is view child and content child? View child in Angular provides access to elements, components, or directives defined directly within the component's own template. Content child, by contrast, queries projected content passed into the component via ngContent from a parent, enabling interaction with externally provided child elements. The key distinction lies in scope. View child targets the component's view hierarchy, while content child handles content projection, with corresponding lifecycle hooks like after view init for view child and after content init for content child. Question number 12. Difference between ngContent, ngTemplate, and ngContainer? NgContent enables content projection, allowing parent components to pass HTML content into designated slots within a child component's template. NgTemplate serves as a reusable template reference that doesn't render by default, enabling structural directives like ngIf or ngFor to instantiate it multiple times or pass it via template outlets. NgContainer provides logical grouping for elements without adding extra DOM nodes, ideal for applying directives like ngIf to multiple elements while keeping the output clean. Question number 13. How does Angular handle security, XSS, CSRF? Angular protects against XSS through automatic HTML sanitization, DOM escaping, and strict contextual escaping, treating all values as untrusted by default and sanitizing them before DOM insertion. For CSRF, Angular includes built-in XSRF protection via automatic token handling in HTTP requests using cookie XSRF strategy, which appends tokens to non-safe methods like POST. These mechanisms work together. Angular escapes interpolation and property bindings to prevent script injection, while server-side practices like CSP and AOT compilation provide additional layers against common attacks. Question number 14. What are HTTP interceptors? HTTP interceptors in Angular intercept outgoing HTTP requests and incoming responses, enabling centralized modifications before they reach the server or application code. Common uses include adding authentication headers like bearer tokens to requests, logging request response details for debugging, handling errors globally with custom logic or retries, and implementing caching to avoid redundant API calls. Developers register interceptors via provide HTTP client, with interceptors, in standalone apps or HTTP interceptors token in ng modules, where each interceptor receives the request, optionally clones, modifies it, and passes it to the next handler in the chain. Question number 15. What is state management in Angular? State management in Angular handles application-wide shared data predictably, ensuring consistency across components through centralized stores or reactive patterns. Common approaches include injectable services with behavior subject for simple shared state, NgRx for complex Redux pattern apps with actions, reducers, effects, selectors, and modern signals for fine-grained reactivity in components or services. These solutions maintain a single source of truth, support immutability, and integrate with RxJS for async operations, scaling from local component state to enterprise-level applications. Question number 16. What is NgRx and when would you use it? NgRx is a Redux-inspired state management library for Angular that implements unidirectional data flow using a single immutable store, actions, reducers, effects, and selectors. Use NgRx in large-scale applications with complex shared state across multiple components, where predictable state transitions, immutability, and time travel debugging via the dev tools are essential. It excels when simple services or signals fall short for enterprise features like async side effects, entity normalization, or audit trails, but adds boilerplate that suits teams prioritizing scalability over simplicity. Question number 17. How do you share data between components? Angular shares data between components through established patterns tailored to their relationship in the component tree. Parent-to-child communication uses at input properties to pass data down the hierarchy, while child-to-parent employs at output with event emitter for upward events. Sibling components share state via injectable services, often with behavior subject for reactivity, and global application-wide data leverages NgRx stores or signals for scalable, predictable management across unrelated components. Question number 18. What are custom validators? Custom validators in Angular are user-defined functions or directives that extend form validation beyond built-in options like required or min length. Developers create them as validator FN functions for reactive forms, returning null for valid input or an error object for invalid cases, and apply them directly in form control or form group configurations. Use custom validators when business rules demand specific logic, such as password matching across fields, age calculations, or async checks like server-side availability, supporting both synchronous field-level and asynchronous form-level validation. Question number 19. How do you implement SSR using Angular Universal? Angular Universal implements server-side rendering, SSR, by rendering Angular applications on the server before sending fully hydrated HTML to the browser. Add SSR to an existing project with ng-add at NgUniversal, Express Engine, which scaffolds server files, configures Express.js, handles platform differences via isPlatform server, isPlatform browser, and sets up pre-rendering options. Benefits include faster time to first byte, improved SEO through crawlable content, and enhanced core web vitals, though developers must handle universal-specific concerns like avoiding browser-only APIs during server rendering. Question number 20. What are signals in Angular? Signals in Angular are a new reactive primitive introduced in version 16 for managing state with fine-grained reactivity and automatic dependency tracking. They provide synchronous access to values via functions like signal, computed, and effect, eliminating manual subscriptions and async pipes while outperforming observables for local UI state due to precise change detection updates. Use signals for component local state, derived computations, and simple reactivity. They complement rather than replace observables, which remain ideal for async streams like HTTP or complex RxJS operations. Question number 21. How does Angular handle internationalization? Angular handles internationalization through markup attributes like I18N on elements, text, and attributes in templates, which the CLI extracts into message bundles for translation. Developers create separate builds per locale using ngExtract I18N, translate XLIFF, XMB files externally, then build with locales flags for optimized language-specific bundles supporting plurals, gender, dates, currencies, and numbers via pipes like date, currency. Runtime switching uses Angular's locale ID provider or libraries like ngXtranslate for dynamic content, while build time I18N ensures smaller bundles and SEO-friendly static translations across multiple languages. Question number 22. What is the role of Renderer 2? Renderer 2 provides a safe, platform-agnostic interface for DOM manipulation in Angular, abstracting direct element ref.native element access to ensure compatibility across environments. It supports server-side rendering by avoiding browser-specific APIs, web workers without DOM access, and security-safe operations through sanitized inputs that prevent XSS vulnerabilities. Common methods include create element, set style, add class, append child, and listen for events, all invoked via injected renderer 2 instance typically with view child for targeted elements. Question number 23. How do you test Angular applications? Angular applications use a comprehensive testing pyramid with tools integrated via the CLI for reliable coverage across layers. Unit tests with Jasmine assertions and Karma runner target individual components, services, pipes, and directives using testbed for dependency injection and async utilities like fake async, tick. Component and integration tests verify interactions via component fixture, while E2A tests with Cypress or Playwright simulate real user flows against the running application for end-to-end validation. Question number 24. What is testbed? Testbed is Angular's primary testing utility that configures a dynamic testing module to simulate the dependency injection container and component environment. It enables developers to declare components, provide real or mocked services, import modules, and compile templates via configure testing module followed by create component for component fixture instances. Testbed handles dependency injection, change detection, and DOM access, making it essential for isolated unit tests of components, services, directives, and pipes with methods like inject, override provider, and fixture.detect changes. Question number 25. How do you migrate an Angular app to a newer version? Migrating an Angular app to a newer version follows a structured process using the CLI's update schematics and official migration guides to handle dependencies and breaking changes systematically. Start by updating Angular CLI globally, npm install Angular CLI latest, then run ngupdate Angular core, Angular CLI to automatically update core packages, migrate configurations, and apply code mods for API changes. Follow up by addressing third-party dependencies with ngupdate, consult the Angular update guide for manual fixes, run comprehensive tests to verify functionality, and incrementally update across major versions to minimize disruptions.
Thanks for watching. Don't forget to like and subscribe.